Hello, students, and welcome to the continuation of our lesson or discussion on problem solving with functions. And I have another problem here there for us to work on. It says, on a 560-mile trip, the Bruins basketball team spent 2 more hours on the highway than they did on the local highway. So I should really fix this problem on this should say interstate highway, um, just to have a distinction between local and interstate. They average 45 miles per hour on the local highway and 55 miles per hour on the interstate highways. How many hours did they spend driving on the local highways? Okay, and this is a very tricky problem because there's a bunch of things going on here, a bunch of different variables. So let's just try to understand the problem. So the team drove for a little bit or some period of time on the local highway. They drove some other amount of time on the interstate highway, and they drove a total of 560 miles on this trip. And in altogether, they average about 45 miles per hour on the local, 55 miles per hour on the interstate. And so to devise a plan here, I'm going to start by just writing down a bunch of variables and keeping track of them, and particularly their units. Okay, so the units here are very important because we got a bunch of different units going on here. So we have something, look, we have a unit in terms of miles. Okay? We have some units in terms of hours, and then in speed. Okay, so actually 3 different units that are happening here: distance, distance, time, and speed or rate. Okay, so it's important to keep these things straight and make sure that our units make sense. So the first thing I'm going to say is that x is time on the local. Since that's what we're solving for, I'm going to use x as that variable, and this is in hours. Okay, and it's essential, again, that we keep track of our units. Next, I'm going to say that x plus 2 is the time on the interstate. Okay. So on the interstate, because that's what it says here, that they spent 2 more hours on the interstate than they did on the local. And these units are also in hours. I also have a distance, 560. And this is the measure of distance. And that is, of course, in miles. I have a couple other numbers here, 45, and this is speed or rate, and this is in miles per hour. And also 55, that's also speed in miles per hour. And one of the common errors, or one of some things that people really do often here, is they just go, oh, well, we'll just take distance divided by speed, and that'll tell us how much time, or speed times distance, and that'll tell us how much time. Okay, but that's really a mistake because they didn't drive 45 miles per hour the entire way. They did not drive 55 miles per hour the entire way. They drove some amount of time at this speed, some other amount of time at this speed, and somehow they ended up driving 560 miles. Now the answer that we're looking for should be in hours. It's a unit of time. So I'm going to give myself a little bit more room here, and I can kind of work with this now. So one of the things that I know, okay, so we know for sure, is that the distance, okay, distance on local plus the distance on interstate is equal to 560, because this is really the total distance. That's really the total distance. And now, I wish I knew each one of these distances because I'd have the answer already, but I don't know that, so I need somehow to be able to use this information here. I need to use speed, okay? I need to use the other speed, and I have time in here as well. So one of the things that we do know is that if you take speed and you multiply it by time, you will get distance. So speed times time, or multiplied by time, will give you distance. In other words, like if you go 45 miles per hour for 2 hours, you get a distance of 90 miles. Okay? So with that in mind now, we can actually use this in our work. So we can say that, look, the speed, this is the speed on the local, times multiplied by the time on the local is equal to the distance in the local. So 45 times x, and this is this 45x represents the total distance on the local roads. Let me use a different color here. And then we also know that the speed on the interstate times the time on the interstate will give me the distance on the interstate. So plus 55 times x plus 2, and that's going to be equal to our total distance, which is 560. And once you get to this point here, this is the toughest part. After this, you can solve this as a fairly basic algebra problem. But once you get to this point here, you should think back a little bit. Do all the units make sense? 560, that's a measure of distance. 45 is speed times time, which also gives us distance. 55 is speed, x plus 2 is time. Multiply those two together, that also gives us distance. So I have distance plus distance equals distance. So the units make sense. And from here on, it's a problem of solving an algebraic equation. This is plus 55x plus 110 equals 560. This is 100x plus 110 is equal to 560. And then we're going to subtract 110 from both sides. That gives me 450. Divide both sides by 100, and that gives me 4.5 hours. 4.5 hours. And that's my final answer. I'm not really done yet. I should go back and look at this and just see if this makes sense. So 4.5 hours times 45 miles per hour. So I'm just going to check here. Okay. So 4.5 hours times 45 miles per hour. And this should give me 202.5. And that's how many miles it must have gone. This is just the local. That means for the highway, I must have gotten, for the interstate, I should say, interstate, it's 2 more than that, x plus 2, so this should be 6.5 times 55 miles per hour. 6.5 times 55 miles per hour will give me 357.5. And if I add these two up, 202 plus 202.5, excuse me, 202.5 plus 357.5, does that really, well, let's see what that equals to. That's, that really does in fact equal to 560 miles. Okay, so from that, that will give that this is a great check for our problems, and that we did in fact get the right answer. And we can think back to this. Remember that our answer, x, should be a unit of time. Should be a unit of time. Our answer is 4.5. This is in fact a unit of time. So that is the correct answer. All right, so now I have another problem here. It says that Ruth is weighing 2 job offers from the sales department of 2 competing companies. One offer is a base salary of $25,000 plus 5% of the gross sales. The other offer is a base salary of $20,000 plus 7% of the gross sales. What would Ruth's gross sales total in order to make the second job offer more attractive than the first? So let's look at this. You got 2 jobs. Job 1, the pay for that is $25,000 plus 0.05 times X. And I really need to define my variables right now. Okay, so X is the gross sales. In other words, how much money she's bringing in for the company in terms of sales. Job 2 is equal to $20,000, so she's getting paid $5,000 less, but she gets a bigger percentage of the sales. So let's say she sold nothing. This job would pay her $25,000. This job would pay her $20,000. Let's say she sold like $1 billion. Well, this 0.07 here is going to bring in a lot of money, and it's going to overshadow this one. But we want to know, like, where is the margin? Where is sort of the cutoff point where the second job becomes better than the first job? Okay, and so when we look at things like more attractive than something else, this usually indicates some sort of inequality, and we can actually solve this both ways: one algebraically and one by graphing. So I'm going to take a look at the algebraic method first. And if you decide to proceed graphing, that's perfectly fine. You should check that. You should do that and then check it with my solutions. And I want to know, where to make the second job more attractive than the first. So I want job 2, and this is total amount of salary here that we're talking about here. I don't want to be sloppy. This is salary, okay? So this is actually money that she's making every year. So I want the salary of job 2 to be greater than the salary of job 1, and we can substitute in our values. Job 2, 20,000 plus 0.07x, somehow greater than 25,000 plus 0.05x. And we're basically just solving for x. So subtract 0.05x from both sides. I get 0.02x and 20,000 still. Subtract 20,000 from both sides, and you get 0.02x is greater than 5,000. Then divide both sides by 0.02, and you get x is greater than 250,000. And this is, so she has to sell $250,000 in sales in order for the second job to pay her more than the first job. And let's test this out. Okay, so let's test and see if this actually does work. Okay, so let's say at 250,123. For job 1, she's going to make 25,000 plus 0.05 times 250,000. Okay, let me move this up here. And that's going to give her a total of, enter this here, $37,500. Okay, so that's with job 1. With job 2, 25, she's actually going to make 20,000 plus 0.07 times 250,000, and that is going to give me a total give her rather, a total of 37,500. And so you see that if she sells $250,000 worth of sales, these two numbers are equivalent. If she sells more than that, the second that she sells more than that, she's going to make more money with the second job. So that's one way you can test. Let's try this again. I'll show you my calculator here. What if she sells more than that, and she sells like, let's test this with, I don't know. Let me get my screen here. So you see here that if she sells $250,001, then for job 1, she's gonna have 25,000. Gosh, this calculator is really hard to see. She's gonna have 25,000 plus 0.05 times $250,001, and that's gonna give her $37,505. if she sells for job 2, she's gonna have 20,000 plus 0.06 times $250,001, and that's gonna give her $37,500.07. And so you can see here that as soon as she sells just at one more dollar than the threshold, she's gonna make a little bit more money with the second job. Okay, and so there you have it. That's the solution to our problem. We followed through all of the process. We devised the plan. We wrote some equations and some variables, and we solved for them. And then we kind of looked back and checked and make sure that all of this stuff really does make sense. And again, this is a very challenging process. You're meant to struggle a little bit, keep working through it, be patient, be perseverance, have perseverance, and you're gonna be okay. Have a wonderful evening.